Hello, I wanted to make a video that talks a little bit about public encryption key software and their use to possibly protect creators of content against illegal copies, excerpts being taken out, or artificial intelligence deep faking individuals' likeness and their voice to make statements that they don't endorse and pretending to be them. So you'll see here at the bottom of my screen, I'm using OBS software recording on a Linux operating system. Down at the bottom I have the logo for the GNUPG, otherwise known as GNUPG or GNU Privacy Guard, which is a open source public encryption key software that's extremely prevalent in the Linux operating system, but it's also available in for download for other operating systems, including Microsoft Windows, Macintosh operating system, and Android. There's open source versions of it that can work. So it's cross-platform. There is email software that's able to use it as well. In particular, in the Linux sphere, one that has plugins that work well for it is Thunderbird. And I'll show a website that demonstrates that here in a moment. Yes, if you go to emailselfdefense.org, it'll redirect to the Free Software Foundation's info page. See how that redirected. So it's emailselfdefense.fsf.org/en, but if you just do .org after email self-defense, you'll get to this website. And it's basically writing from the perspective that, we live in a surveillance society where your data is being copied by government agencies to evaluate you, or maybe sometime in the future they could backtrack and look at all of your data that's been streamed on the internet, look at all your emails that have been sent. And so, against that, they say everybody should use encryption. But also there's a lot of hackers, and also just it's good practice to be able to have data that's being able to be verified for being intact, that no bits have been altered in transit just by some problems with the internet, so that if you're sharing software or a document, it hasn't gotten a bug put in it, or something more malicious happening. For example, an email phishing scam, someone pretending to be someone that you know, but really it's some hacker trying to get information, social engineering you. And so they walk through getting the pieces, setting up an email program. In this case, it's Thunderbird to use your email, installing the GNUPG software, and that it's available for multiple operating systems. Making your keys. So it's important to make a key pair. So that includes a really strong passphrase that's kept secret, and that creates a private encryption key. So you keep that key private, and it's a key pair. So there's another corresponding public encryption key that you actually would share with other people, and ideally the other people would verify that that public key belongs to you, and that's an identity verification step. And when put together, it creates a web of trust. It's decentralized encryption keys that are, identities that are trusted. And you could be your legal name and everything with an email address that you want to share and keep, or you could have a pseudonym with an email address that's maybe disposable that you're using for some project that you're doing that you don't want to share that with. But anyway, the sky's the limit with that. So they tell you about how to secure your passphrase, uploading your key to key server, so it could be shared and downloaded in a nearly automated fashion. But also you could publish your key on a website, your public encryption key, make it downloadable so people can import that key into their software and be able to use your identity for encryption or for verification of data that you send to them, and vice versa. They should do the same for you. Share their public key, you should verify their identity, and then you can verify data sent from them. And if you so choose, you both could encrypt to each other, and then only you guys can decrypt that information. So no one else could read your data that's being transmitted. So email encryption can be set up with Thunderbird pretty easily. There's a package called Enigmail that gets plugged in there, and so this website will walk you through the steps to do that, and it allows you to try it out with a bot named Edward, I believe after Edward Snowden, that you can send an encrypted email to, and they can write back to you, and you can do a key exchange with them and see how to do that. So you could practice with a bot, and then you could practice with other people, maybe a friend or somebody that you know that is also interested in doing this. I think it's important to do. And the web of trust, they talk about that. That's an important aspect that gives this decentralization some power and allows those keys to have identity verification and trust. And that trust, might not be the highest level, might be a little bit lower, depending on how well you know somebody and how well you check their keys out. And that key signing can be shared online as well. And knowing about fingerprints for the identities, for example, the long serial number looking thing is the long version of the key, and that's harder to spoof than a short version because there might be some other random bits, and then the last bit might be the same between two keys. So sharing just a key ID is a nice shortcut to not have to remember all this or copy it, but it could be spoofed, and they talk a little bit about that. And they talk about when to consider signing keys, when you should encrypt and when you should sign, being careful about invalid keys, about what to do for revoking certificates, and to act swiftly if someone were to compromise your system and get your private key. You'd want to revoke that, although without knowing your passphrase, especially if you made a strong one, that key's pretty useless to them. And webmail and GNUPG, how you could use that. You can if you're using webmail, you could display plain text encrypted text, but you would have to copy it and decrypt it maybe outside the webmail, and that would be very secure. So if you're using something like Google Mail, you could still send encrypted messages, and Google can't read anything in there, but you'd have to have some software that decrypts that message, and Thunderbird is able to do that and almost automate it, but you got to be writing in plain text. So there's some learning to do and experimentation. And using your public key as part of your online identity, I think is really important. So this web page explains about email self-defense. But that gets me an introduction to why I have the logo down here on the bottom of the page. And I'm saying this video is digitally signed by GNU Privacy Guard key and has the long key fingerprint. And it says this permits data verification, the authenticity of the source file data, its integrity, and the creator ownership. And I have a copyright on here, and I say all rights are reserved. Any excerpts and or modifications are strictly prohibited and will be unverifiable with the GPG public encryption key. So in other words, if I share this video, say I upload it to YouTube, in my description I can say go to my website at a certain address, and you can get the full version of this file that has been digitally signed by me, and you can download my public encryption key, and you can download the signature files, and you can verify that that file was created by me and is authentic. So if a person were to make an AI version of my likeness and my voice, they might be able to say the opposite of everything I'm saying, or whatever, misinformation, and they will never be able to digitally sign with this key fingerprint that has been around since 2021. They might be able to make a new digital fingerprint that would be newer. Maybe there's a way to spoof it, make it seem older. I'm not aware of that. But they wouldn't be able to have this key fingerprint and this digital identity. And I would be able to say, hey, I don't control that key, someone else does, pretending to be me. Or their key will, if they try to use my public encryption key, it will never be able to verify the authenticity of a file that I didn't create. So that's what I'm basically saying there, and that's important. I just put it here in this long format just as a proof of concept. I don't know if this is the most ideal way to do that, but some sort of a description and a link to the original source file would be very important. When you upload things to social media, things get changed. Data is going to be altered, so that would break a key's fingerprint. So if you were to download the file from, say, YouTube, it may be transcribed into a different file format in order to allow it to play on their service. And that process, when you download that, then it's a changed file, so it would not be an intact signature. So one would have to pay attention to every nuance in the file and see if the content is identical or not. And but that's beyond the concept here that I'm trying to exemplify. So I'm going to open my Emacs text editor, and this is just some of my thoughts. It's basically a recapitulation of what I just said. So this is my January 18th, 2024, which will be the date of signing on this document. This is one of my musings. I'll probably create into a web page with a link to this source file that I'm creating right now that I'm recording. So I heard a recent piece on the radio, I believe it was NPR, where they were spreading some fear about AI and the ability to deepfake audio and video to spread misinformation. For example, there was an audio that sounded a lot like, but not exactly like, Donald Trump, and I believe he was criticizing a governor or something in this, and it was for Iowa's caucus, and it was actually created by the Ron DeSantis super PAC. Created this pretending to be Donald Trump saying something bad. And if this is on the radio, some people might think it really is Donald Trump. So that's some misinformation. I think that's pretty shady dealings. I don't know what to think of Ron DeSantis, but the fact that a super PAC did that on his behalf is kind of disgusting. And we worry about our foreign governments using AI to make things a fool people on social media. So how can you get around that? And so I was thinking that a way to make any data that's being shared verifiable in a decentralized, liberty-respecting way, and that's important too. You would have to use something like the GNU Privacy Guard public key infrastructure, and because this is decentralized, this is end users downloading the software that's free, libre, open source, making their own keys, sharing their keys with each other, and creating a decentralized web of trust, rather than some organization or an agency or a government saying this is your key and your identity and you have to use this online. You could create your own and say this is the key I'm using and for this time period or this content, and you have control rather than somebody else imposing their control on you. And I think that's really important. We should be educating ourselves and our elected representatives, whether they're from your ideology or from an opposing ideology. I think all of them should be respecting this and protecting our freedoms. The freedom of speech is one of the first freedoms in natural law perspectives, and I think this is part of free speech. And having privacy is also an important natural law, and I think we have an expectation of privacy. So if you encrypt things, you're saying, hey, I have a strong expectation of privacy no matter what end user license agreement I signed. I'm encrypting this data. If someone breaks my encryption using, say, quantum computing or something, they're violating my rights. They better be going through some legal process and proof beyond reasonable doubt that they had the right to do that, and that all should be able to be challenged and or thrown out. So if one's doing something criminal, then you have a right to due process, and you're innocent until proven guilty. But anyway, I'm going down a rabbit hole there. But this is all important. So I've been using GNU Privacy Guard since 2007. I have a key that's from 2008 that I have published online as well, and it has signed the integrity of the key that's referenced here from 2021. And public key infrastructure enables the web of trust that I was talking about a couple times now, and that allows the key pair and the exchange of public encryption keys with others, and the data can be clear signed. So you don't have to have encrypted data to have it signed. It can be totally interpretable. This video can be signed and it's not encrypted. Everybody can read it. The text in this document I can digitally sign with clear text. It doesn't have to be encrypted to anybody, but it can be. I'm signing that I'm the person. This digital identity signed this. So anyone that downloads it, that data along with the key, can verify its integrity and the trust. Basically, the private key and my secret passphrase allows me to create that signing, and the public key allows other people to verify that signing matched the data that's being exchanged. Therefore, any data, text, a software program, a script, an audio file, a video file, any creation, anything that's digital, is able to have a file owner and originator of the data to create a signature file. If a single bit of information is changed, then that signature for that changed file will be broken. It'll be reported as being bad, so it can't be trusted. Something's wrong with it. Something's been altered. It won't tell you what, but it'll just say something's different. Whereas if the entire file is totally intact and hasn't been changed in any manner whatsoever, then the data, when it's being verified, the attached signature file will report it as being good, that the data is good, it's intact. So if I create this file, for example, and I make a video of me creating it, which I'm doing right now, I can attach both this plain text file that I'm writing and the video file, and I can make them downloadable. And I'll also put my public encryption key available for download that has this key ID, and my digital signature for the files can be verified. If someone makes an AI generated likeness or an appearance or voice of me and creates something, they are never going to be able to make a downloadable copy that has been signed by my GPG key. If I create something and I want to verify that I approve of it, I can digitally sign a copy of the file that I want to verify and provide it as verifiable proof. So, and I can do that after the fact. I can do it at any time. I can just say, hey, I made that. Here's a copy of what I made, and I'm signing it now. Or I could do it, at the very beginning of creating it, as soon as I finish, before I share it. So let's show how this would happen inside a text file. You can actually encrypt parts, digitally sign or digitally encrypt parts or regions of files in a text editor such as the GNU Emacs program. So if I highlight a region of text, I can then tell it to sign the area. So you'll see that this is what it would look like. This region inside here that I'm highlighting has been digitally signed, and we can verify that signature. And I'm going to do this a little bit backwards because it's already signed. I'm going to verify it. Then I'm going to delete this data, these bits, this begin PGP signed message and this begin PGP signature. I'll delete that after. What we do is we go to Tools. I have my encryption keys already in this computer, and I have one that's defaulted in the Emacs. And you can look online how to do all of that. This video is not about that. Verify the region, and it's saying replace the text. I'm going to say no, I don't want to replace the text right now. So it's going to open another little window or a panel or a pane or a buffer really to show the text after this has been verified, the text that's been verified. Then it'll have a little information panel saying whether or not it was a good signature. So no, I don't want to. So here's what it said. This region of text within this document has been digitally signed by GPG key belonging to Stephen C. Morrell, and my email address, the copyright, and that all rights are reserved, excerpts and modifications are prohibited. So that was the region that was encased in that PGP signature. And down here it says good signature from that identity that's being mentioned. And on this computer, the trust is ultimate because I'm the ultimate owner of it. So I trust that key ultimately. If you were to download my key, you would have to verify my identity, and then you can assign the level of trust you want to give to me and how well I'm able to sign keys, verifying people's identity. I'm pretty good at it, but I wouldn't say I'm an expert, but I'm very knowledgeable. So it's a good signature, and it also says the date of creation. So it says today's date, and it has a time stamp, and it says that it was using RSA. So let's go back into just this pane, and we're going to go back up here. I'm going to show how I did that. I'm going to delete this part above here that says begin PGP, do some deleting that out, and I'm going to delete the signature part, and I'm going to show how this was created. Backspace. So now I'm just highlighting this region of text, these two lines of text basically that say this region of text within this document has been digitally signed by this key, and it has a copyright. It's just a proof of concept. Tools, encryption, decryption, and I want to sign that region. So now I get a pop-up because I'm the owner and creator. It's looking at my private key that is installed on this machine, and someone else, they could steal my computer, sit at my computer, but they're not going to know my passphrase. So I have my passphrase memorized. If I can spell it right, then I'll get it right here. Or type it right and spell correctly or whatever. I think I got that right. And I'll say okay. And I typed it wrong. And you get 3 tries. So let's see how that works. There. Okay, so if you type it in correctly, if you put it in incorrectly, it will say bad and it won't let you sign. But if you know the passphrase and you have the private key and you type in the passphrase properly, you remember it and type it in properly, then it will create a signature. So, and then that signature is able to be verified as we already did. So this is a little bit redundant. You just would do that in here, tools, verify region. No, I don't want to. And it shows that text again and that it was just signed at this time. Okay, 13:59, 15 minus 500. So I'm in East Coast time. It's 2 p.m. So I think that's accurate. Yeah, it's almost 2 p.m. So 1400 would be 2 p.m. So so that shows that it was just signed just now. And I would save this file. And so if I upload this file, which is a .org file, then it can be opened. It doesn't need to be an .org file. I did that by accident. It can be opened in a plain text editor. But let me see here. Where am I saving it as? Save as under documents. Okay. Anyway, I'm getting a little bit. This is out of the scope of this video to show where my files are, but I can just show you that I can open this .org file in a plain text editor. So let's see, where's the AI one? AI. All right, let's see. AI GPG. All right, let's open with the plain text editor. Here it is in a plain text editor. It just looks, this is a plain text editor. The way I have it set up has a blue background. But yeah, but this text editor doesn't have the ability to verify anything. So I like the Emacs program. So if I open Emacs, it has another view. So anyway, that's, so if a person were to open a plain text editor, they could copy this out of here, this whole section, and put it into the GPG software and verify that segment. It's a little more complicated. I love using Emacs because it was so easy. So I recommend installing Emacs and any plugins to use GPG encryption. But anyway, proof of concept. I can make a file and encrypt it if I want it to be private, or I can plain text sign it if I want to sign it. So so I've saved this file. I can now in this program, I believe this can sign a file. Yeah, okay. So it's under documents. I'm calling it AI. What do I call this file? AIGPG.org. So let's find that. There it is. So if I click this, I'll say OK. And it should have created a signature. Let's see if that's in that folder. Sort of learning as I go here. I sort of know how to do it. Documents. So let's see here. We got an AI. There it is. .asc. Let's open that with a text editor and see what it looks like. Okay, so you see how it has a signature at the top, and that's sort of like a kind of like a parenthesis. Here's the beginning, everything all the way down until the end parenthesis, the signature for the whole document, and then there's another one. So it's like two of them inside each other. It's like a sandwich. This other PGP message can be verified. So if we were to open this instead of a plain text, if we were to open it with Emacs, open with Emacs. Whoa. Let's see here. All right, so this is that .asc file. So this is the one that's been signed all the way through and through. If we highlight the whole thing, it should be a timestamp later than 2 o'clock. It's probably 2:04 or something. Now we go to Tools, Encryption, Verify Region. No. So now it took off the brackets for that, and it still has the other signed message inside. And it says it was a good signature and that it was done at basically 3 minutes after 2. So that was the last I signed that digital file. So I can do that for this file because it's a plain text file and embedded in the signature in the plain text. So that can be done. Let's see if it'll let me verify the file. So let's see, file, oh no, tools, verify a file. It's saying what file do you want to verify? I want to verify, let's try the .org one and see what happens. I don't think there's anything to verify there. It had a good signature. Okay, so it knew that signature was good. Let's try to verify the ASC file. Tools. Okay, let's first get rid of this window so we're not confused. Tools, encryption, decryption, verify file. We'll do the ASC one. Open. That's a good signature too. So, and that's from 403. Let's do that one more time. Did I click the wrong one the first time? I'm surprised it was able to verify the one that didn't have the data in it. Probably because it was looking for the .asc right next to it. Tools, encryption, verify file. This is the .org one, not the .asc. I think it's going to just use the ASC to help verify it. Open. I got a good signature with the same timestamp. Oh no, it verified this signature inside this segment. So that's interesting. So that spoofed it. See, it's a different time. It was verifying the contents inside this file, and the content was just this part because we checked that earlier. So it was not verifying the entire file. It was just verifying, but it doesn't let you know that. So there, that was good. That was a little bit of learning from actual doing, and I think that's important. So be careful if you put a segment in here. Somebody could write stuff up above this and say all kinds of horrible things and claim that you wrote it and you signed it on this date because this is in here. But if a person actually with knowledge goes in and says, no, that wasn't signed, just this little part was, then that's how that could be demonstrated. And again, we'll show that by highlighting this section, and we will verify that region. It'll show that exact same timestamp, the 1359. So let's verify the region just to redemonstrate that. 1359, so that was the part that was verifiable. So it's not verifying the rest of the data. So I should have probably just highlighted the whole thing, but that's what that other signature does with the .asc. So I would probably just share the .asc so that can't be done. So that's the solution to that dilemma. So the dilemma is don't share the .org, share the .org.asc file, not the plain .org one, and then that'll work. So yeah, so that's so we'll close that. Let's file close. Let's file open. Documents. The API is or AI. We'll open this file. There we go. So, all right. So it has two signatures in it. So that's okay because we can highlight that, just that one signature right here. Let's see what happens if we do the first dash. This is learning on the fly here. Verify region. Unable to verify region. All right, because we included that extra dash. I wonder if it'll do this one. Buffer. Verify region. I bet it'll fail. Yeah, I can't verify this with the dashes here. See the dash at the beginning? But we can select all. Tools. Encryption. Verify region. No. And then this is the version of the document that has been verified. And then we can do it again. We can highlight this part to this part. And we can tools, verify region. No. And that little part has been signed. And you see that's a 1359. So you see how we did it in 2 steps. And that's the way to do that. Because they're like parentheses, like doing mathematical operations inside parentheses. So the first math is the verification of the whole document, and then you get an output, and then the second math is a verification of the next clamshell inside there, and then that works. So that hopefully that's a good explanation of how that sandwiching would work. And that's good that I made it as a video, so if somebody was like, hey, this isn't working. So it does if you follow what I just did. All right, I'm going to close this. I think that's it for this video. It's probably going to be like a gigabyte of upload, which I'm going to actually put on my server for a little while. And I'm going to upload this video probably to YouTube and see if anybody finds it interesting or useful, and we'll see if I leave it there or not. I really don't want to spend a lot of money storing videos on my personal website, but for this example, I think it's kind of neat. Thanks for watching, and I hope you have a great day.